Hello everyone. Welcome back to the Basic Electrical Engineering lecture series. In this session, I'm going to discuss what is the meaning of Fleming's right hand thumb rule, how it helps to identify the direction of induced EMF and current in the particular DC generator. So moving on to the discussion, we have already seen the operation of DC generator. So a coil or a conductor which is placed over there. We have two magnetic pieces like a north and south pole. You are trying to rotate the coil in the particular magnetic field at that time, and induced EMF is generated in that particular coil. So our ultimate goal is to identify the direction of induced EMF, the direction of current, the motion. That means you are going to rotate the direction of motion also we have to identify. For that purpose, we are going to use Fleming's right hand thumb rule. First, what you are supposed to do is stretch your thumb. This is your thumb, correct? Stretch your thumb. This is your forefinger. Forefinger. This is your middle finger. In mutually perpendicular direction. So like a mutually perpendicular direction means like this. This is your mutually perpendicular direction, like 90 degree. This is also 90 degree, and this also should be 90 degree. Mutually perpendicular direction. So we have to keep your thumb, then your forefinger, then your middle finger in the mutually perpendicular direction. Now you can directly point out, go back to the previous slide. Let us go back to the previous slide. You can point out your forefinger in the direction of magnetic flux. You know, magnetic flux that will always travel from North Pole to South Pole. So keep your forefinger. You can keep your forefinger in the same direction as that of magnetic flux. Magnetic flux. We are considering the magnetic flux that will be moving from North Pole to South Pole. Group of magnetic lines of force will always take a path from North Pole to South Pole. So you have to keep the forefinger along with the direction of magnetic field. Next, what is happening is you can identify the thumb represents the thrust. Thrust is nothing but just basically a force, thrust or motion, because you need to rotate. Definitely there will be a movement or a motion. Okay, that is represented by thumb. If I talk about like a middle finger, that will be representing in the current. What about the current? Because you are going to connect the commutator. A commutator, like a brush segment, will be directly connected to the external circuit. So definitely a certain amount of current passes through the external circuit that you can identify by using the middle finger. So this is actually called Fleming's right hand thumb rule. So basically these three fingers that gives the direction of thumb, then magnetic field, then current, that you have to remember. Okay, you have to stretch forefinger, middle finger, and thumb in mutually perpendicular direction. Initially, point out the middle finger. Sorry, point out the thumb. Sorry, point out the forefinger towards the magnetic field. You know, you have to assume that magnetic field, that the movement of magnetic lines of force from North Pole to South Pole. Later, you can identify the thumb and middle finger uh, for identifying the direction of motion as well as current. Thank you so much for watching this video. Let me know if you have any queries. Happy learning.